Have you ever looked up at the sun and wondered, why does it look yellow? After all, space photos show it as white. Well, today, we're diving deep into the science behind the sun's color and uncovering why our eyes see it the way we do. Get ready to explore physics, atmospheric effects, and even human perception. Let's start with a fundamental fact: the sun isn't actually yellow. It's white. If you were to travel into space and look at the sun without Earth's atmosphere in the way, you'd see it shining as pure white light. But why does it appear white in space? The answer lies in the nature of light itself. Sunlight is made up of all colors of the visible spectrum, from red to violet. When all these colors combine, they create white light. You can see this effect when you shine light through a prism. It splits into a rainbow of colors. This tells us that the sun emits all these wavelengths equally, making its true color white. So why does it look yellow from Earth? The answer lies in how our atmosphere interacts with light. When sunlight enters Earth's atmosphere, it encounters air molecules, dust, and other tiny particles that scatter the light. This process is called Rayleigh scattering. Here's where things get interesting. Different colors of light have different wavelengths. Blue light has a shorter wavelength than red and yellow light, which makes it more likely to be scattered in all directions by the tiny molecules in the atmosphere. That's why the sky appears blue. But because so much of the blue light is scattered away from our direct line of sight to the sun, what we see is the remaining mix of colors, which leans toward yellow. This effect isn't the same everywhere. On Mars, for example, the atmosphere is much thinner and full of fine dust, which scatters light differently. That's why the Martian sky appears more reddish during the day, and sunsets on Mars have a bluish tint. The way we see the sun's color depends entirely on the atmospheric conditions of the planet we're viewing it from. You can see this effect even more clearly at sunrise and sunset. During these times, the sun appears much lower in the sky, meaning its light has to pass through even more of the atmosphere before reaching our eyes. This causes even more blue and green light to be scattered away, leaving behind mostly warm tones of yellow, orange, and red. That's why sunsets and sunrises are so breathtaking. Now, does the sun actually change color? While its daily appearance is due to atmospheric scattering, the sun will undergo real color changes over millions and billions of years. Right now, it's a stable main sequence star, burning hydrogen and emitting white light. But in about 5 billion years, the sun will exhaust its hydrogen fuel and expand into a red giant, at which point it will genuinely look red. So while the yellow sun we see today is an illusion, one day it really will change color. One more factor to consider is how our own eyes perceive color. Our eyes are more sensitive to certain wavelengths of light, especially green and yellow, which may make the sun's slightly filtered light appear even more yellow than it actually is. Our brains process light in a way that's not just based on physics, but also on human biology. So, to recap, our sun is actually white, but it looks yellow from Earth because of the way our atmosphere scatters light. This effect changes depending on time of day, location, and even what planet you're on. And while the sun won't be yellow forever, for now, our atmosphere and our eyes combine to give us the familiar golden glow we see every day. If you enjoyed this deep dive into the science of sunlight, don't forget to like, subscribe, and hit the bell icon for more cool science facts. Thanks for watching, and see you next time.